As the video starts rolling, I just want you to bask in the beauty of my drawing. That stick figure, perfectly proportional, as well as the rock. With that being said, hi guys. I just wanted to show you that this whole quarantine is having negative impacts on my hair. This has absolutely nothing to do with work and efficiency, although we talked about the water cycle in the last video I made for my 7th graders. Somehow my hair got wet and I'm just going to roll with it. So I'm in at school today. I've got my big whiteboard. So we're going to go ahead and look at the beauty of my picture and discuss how it impacts efficiency, mechanical advantage, all that jazz. So, question for today is, can you ever get more work out of a machine than what you put in? So, best way to describe that is to work backwards from efficiency. So efficiency is basically how good a machine is at getting work out of it, okay? Hint, you're never going to have a machine that is 100% efficiency, and that is because of friction. So when you're doing this today, think about, is an automobile, which is a compound machine, has a lot of machines working together, is that more or less efficient than, say, a lever? Has to do with friction. Just ponder that for a moment. Is it awkward yet? Good, we'll move on. So, it all comes down to work in versus work out. So, when we go ahead and look at the lever, when you go ahead and push down, that's going to be your work in, or your work input. Okay? Now on the flip side, you're going to have work out on this other side here. So remembering that work is force times distance, when you go ahead and move that rock, if this is, say, 1.5 meters, the distance from that guy's armpit all the way down to the ground that he can push that lever, is it going to move that rock the same distance? Chances are it's not. It might only move it, like, let's say 0.15 meters. But is the force going to be as great that he's moving it on over here? So what we need to look at is, by using a machine, you're going to be able to generate a greater force over here on the work output side. However, it's going to be over only a very small distance, not as large of a distance. So in this case, your trade-off is you're taking a smaller force, but exerting it over a greater distance in order to get a greater force over here over a lesser distance. Okay? So that's kind of what's happening with machines. There's a trade-off, because you never get more work out of it than what you get into it. If that be the case, you'd have efficiencies over 100%. That's incorrect. It's never going to happen due to friction. So what we need to understand here is the reason why we use machines, the reason why they're helpful is they can increase force. But they increase force because we're going to go ahead, we're going to exert a lesser force over a greater distance. So think about if I take this chair. If I want to take this chair, lift it up, put it right here. Can you see me? Okay. That didn't take a whole lot of time. I only had to lift it probably, let's measure. I went ahead and I lifted it 91 centimeters. But it took a little bit of force. Now, if I want to go ahead and push that up a ramp, it wouldn't take nearly as much effort. However, it would take a lot longer distance. Because in order to, by building codes, have a ramp that would go up that almost 1 meter, it would have to be probably almost 10 meters in length. Okay? So you'd be exerting a lesser force, but over a much greater distance. So it's always a trade-off because we can never get more work out than what we put into it. So with that in mind, machines, save your back, guys. With that in mind, I'm going to look at getting a haircut.